we're talking about quadratic inequalities. So where have we seen inequalities so far? Well, we've looked at inequalities with graphs, right? When we had to figure out where our y values were greater than or less than a certain value. So let's sort of use that as a jumping off point here. So, for example, let's say we were looking at 2x squared is less than 8x. So what we're doing here is we're looking for all of the x values that satisfy this equation. So what can I plug in for x that makes 2x squared less than 8x? So this definitely doesn't look like what we've seen before, right? The stuff we've seen before has looked more like, when is f of x less than 0 or greater than or equal to 3 or something like that. So let's see if we can make this look a little bit more like that. So that means we should move everything over to one side. We've got 2x squared minus 8x is less than 0. With symbolic inequalities, we want to move everything to one side. We always want 0 on the other side of the inequality. We'll see why that's important in just a second. Okay, so again, we're using our graphing strategy at this point. So let's draw this graph. In order to graph polynomials, normally we start by graphing their x-intercepts. So let's figure out what those are. We can find our x-intercept of a quadratic by factoring, right? So what can I factor out of each term here? Looks like probably a 2 and also an x. So if I pull 2x out, what's left for the first term? Just x. And what's left for the second term? 4. All of that is still less than 0. Okay, we're looking for the x-intercepts, which is where the value of all of this is equal to 0. When we have a bunch of stuff multiplied together and we're trying to figure out where it's equal to 0, we need to check all of the factors, right? For this whole thing to be 0, then either 2 or x minus 4 needs to be 0. So where is 2 0? 2 is 2. It's not 0. Never going to be 0. So that is not going to give us 0. When is x 0? Well, it's kind of a trick question, right? X is 0 when x is 0. So x equals 0 is an x-intercept. When is x minus 4 0? X minus 4 is equal to 0 when x equals 4. So we've got an intercept at x equals 4. Now, we know that our parabola is either going to open up like this or open down like this. We know that either our parabola is going to open up like this or open down like this. Can we figure out which one it is by looking at the equation? Totally. What tells us whether a parabola opens up or down? Our leading coefficient. And our leading coefficient here is 2, right? It's the coefficient of the x squared term. So we know we're opening up. All right, so this is 4, this is 0. What are we looking for? Well, we're looking at where this function, which we've graphed, is less than 0. Where are the outputs of our function less than 0? It's this part, right? When we're under the x-axis. What are the x values that describe this part of the function? Well, it's all the x values between 0 and 4, right? We're writing it in interval notation. Are we including or excluding the endpoints? Well, so we said that these were the zeros of this function, right? These are the roots, which means that that's where we're passing through the x-axis, which is where the output of our function is equal to 0, right? Equal to 0. 0 is not less than 0, so we are excluding these points. That's my answer. So all of the x values between 0 and 4 are where this statement is true, right? If I pick something between 0 and 4, this statement will be true. So for example, if I picked 1 is between 0 and 4, so if I plug in 1 for x, I have 2 times 1 squared. 1 squared is 1, so 2 times 1 is just 1, is less than 8 times 1, which is 8. Is 2 less than 8? Totally. So that's true. If I pick something outside of this interval, like let's say -1, what happens? So we've got 2 times -1 squared. -1 squared is +1. So we have 2 times +1, which is 2, is less than 8 times -1, which is -8. Is 2 less than -8? Definitely not. So it's not true. Any x value that's outside of this interval is going to make this statement false. Any x value inside of this interval is going to make it true. So we want to find all x values here that make this statement true. So let's do the same thing. Let's graph and then see where the graph is greater than or equal to 0. So graphing means we want to factor, so we can graph our x-intercepts. We've got x squared plus x minus 12. We want to figure out something that adds up to 1 and multiplies to -12. Sounds like x plus 4, x minus 3. We want that to be greater than or equal to 0. This means we have the following. We solve for x in both places. We have the roots -4 and 3. Let's go ahead and graph those. +3, -4. Okay. Am I going to be, so we know that our parabola is going to be either opening up or opening down. Which one is it going to be? Well, our leading coefficient is +1, so we are opening up. So our graph is going to look like this. All right, what are we looking for now? Well, we're looking for the part of the graph that's greater than or equal to 0, right? Where our output from the function, right, where the function is greater than or equal to 0. Output, or y, is our vertical height, right? So where our height is 0 on the x-axis. So if we're looking for where we're greater than or equal to 0, it's where we're above or on the x-axis. So that is this guy and this guy. How can we write that in interval notation? Well, looks like we're starting, this is continuing off in that direction. So we're starting at -infinity, continuing all the way to -4. Do we include -4 or exclude it? Well, again, the value of the function at -4 is 0. It's asking for where we are greater than or equal to 0, so yes, we do include it. Union, the second part, 3, do we include it? Again, that's where the function is equal to 0. We're looking for greater than or equal to, so it does count. We have 3 to infinity. So this is my answer. Let's look at one more. So we've got 4x squared plus 9 is less than 6x. Again, we need the other side to be 0, so let's bring everything over to one side. Can I factor this? Not very easily. So what do we have to do when we can't factor? We have to plug into the quadratic equation. So let's go ahead and do that. We have x equals negative b plus or minus square root b squared 4ac over 2a. Let's plug everything in there. So we have negative b is negative 6 plus or minus square root of negative 6 squared minus 4 times a is 4 times c is 9 over 2 times a is 4. So we get positive 6 plus or minus square root 36 minus 4 times 4 times 9 is 144 all over 8. So we've got 6 plus or minus the square root of negative 108 over 8. Okay, what's up with this guy? Well, we have a negative under the square root. Can we have that? No, that doesn't give us a real number. So there are actually no roots, no real roots for this function. So that means we don't pass through the x-axis. That's totally okay. Sometimes that happens. This is totally okay and happens all the time. Right? It either means that my entire parabola is above the x-axis or it's all below the x-axis. Right? This happens. This is totally fine. If I'm above the x-axis, I have to be facing up. Right? Because if I was facing down, I would run into the x-axis, right? Here or here, which would mean I would have roots, but we have no roots. If I was below the x-axis, but I was facing up, I would have to run into the x-axis at some point, but again, we don't do that. So I know that if I'm above the so I know that if I don't have any roots and my parabola is facing up, then I'm above the x-axis. Or if my parabola is facing down and I don't have any roots, then I'm below the x-axis. So what's going on here? Are we facing up or down? Well, we have a leading coefficient of 4, which means we're facing up, which means that my parabola looks something like this. The vertex might be, I don't know where the vertex will be. We could find it, but it's not necessary. We know that our entire parabola is above the x-axis. So if I'm looking here, so now that I know that, all I need to figure out is when am I less than 0? Well, if my entire function is above the x-axis, then I'm never going to be less than 0, right? I'm never going to be in this zone. So there's no solution here. What if I had asked, where is 4x squared plus 9 greater than 6x? Well, that would give us almost the same thing. greater than 0. We're looking at the same function. We're asking, where is this greater than 0? So where is this above the x-axis? And it's above the x-axis for all of our x values. So that is all real numbers. That's just a quick aside. Okay, do we have to do this every time? Do we have to graph every time we're looking at an inequality? No. So let's go back to the notes really quickly. We actually don't have to graph to find the answer to a quadratic inequality. The way we can do that is we can sort of take the bare minimum of things that we need from this graph. So we know we have an x-intercept of 0 and an x-intercept of 4. Let's let this line this number line records where the function is positive, negative, or 0. So we are equal to 0 here. So, and we know that in order to change from being positive to negative, we have to pass through the x-axis. So these are the only places where we change from being positive to negative, potentially. So I can actually pick any point in this region, any single point in this region, and if it's positive, then that means that all the other points in this region are positive, right? Because if we change to negative, we'd have to pass through the x-axis again. So since there's no other roots less than 0, that means that all of the x values less than 0, they're all going to be positive or they're all going to be negative. So let's test one point here. An easy one might be x equals -1. We can see from over here that that's positive, but again, we're trying to figure out a way where we don't have to graph it every time. So let's figure it out. We don't have the graph, so our function is 2x times x minus 4. So we have 2 times -1 times -1 minus 4. So that's 2 times -1 times -5. That gives me positive 10. And we actually don't need to figure out the exact number, we just need to figure out whether it's positive or negative. So I have a positive times a negative times a negative. 2 negatives make a positive, so we have positive. We can record that by writing a positive on top of the number line. All right, let's test something between 0 and 4. We could pick right in the middle, we could pick 2, or we could keep it as small as possible. So I'm going to pick 1. So I plug it in, I've got 2 times 1 minus 4. That gives me 2 times 1 times -3. So I've got a positive times a negative. 1 negative on its own is going to be negative. Again, it doesn't matter exactly what it is, it just matters the sign. And then let's pick something that is greater than 4. Again, going to try and make it as small as possible, so I'll pick 5. That gives me 2 times 5 minus 4. So I have 2 times 5 times 1. All of those are positive, so this is going to be positive. So I have positive, negative, positive. Can I see how that translates to my graph? Well, right, this whole portion of the graph is positive, right? All of these y values are positive. Then all of these y values are negative. And then all of these y values are positive. So we've kind of consolidated that information onto one number line. All that's left to do is find the interval that we want. We want to figure out where our function is less than 0 So are we going to include 0 and 4? What are the values of the function here? Positive or negative? Neither, right? The value of the function at 0 and 4 is 0, right? There are roots. That's what that means. So these are not included. And then less than 0 means negative, so we are going to shade the negative portion. Awesome. So my interval, again, is 0 to 4, not including 0 or 4. Let's give this a shot in our lab manual. So let's go ahead and look at number 4 here. So we've got x squared minus 6x is greater than or equal to 7. We have to bring everything over to one side first. We need to find our roots, right? Because that's where we're equal to 0. So can we factor this? We can. This factors into x minus 7 and x plus 1. That means I have a root of 7 and a root of negative 1. I go ahead and put those on my number line. Negative 1 comes first, 7 comes second. Okay, we want to figure out where we're positive and where we're negative. So let's test a point in this interval. So the smallest number that's less than negative 1 is, I would say, negative 2. All right, let's plug it in. So we have negative 2 minus 7 and negative 2 plus 1. So we end up with negative 9 times negative 1. So we have a negative times a negative or a positive. I'm going to bring this down here so we have more space. What's a good number between negative 1 and 7? Well, 0's a fine number to plug in, right? And it's really nice to plug that in because I can actually plug it into this equation as well. If I plug it in here to see how it relates to 0, right, whether it's positive or negative, all of these terms become 0, so I just end up with negative 7. So this is negative. And last, I want to pick the smallest number that's greater than 7, so I'm going to pick 8. If I plug in 8, I get 8 minus 7 and 8 plus 1. So 1 times 9. 1 times 9 is positive. All right, so what am I looking for? I'm looking for greater than or equal to 0. Because it's or equal to, that means that this time we can shade in our roots, right? Because that's where we're equal to 0. And then what intervals do I want to shade here? Well, greater than 0 means positive, right? So we shade in our positive zones. So that's right here and right here. So we have the interval negative infinity to negative 1 included, union 7 included to positive infinity. That's the answer. And we didn't have to graph at all. All right, it's asking us, how would the solution change if the inequality symbol was greater than? So instead of greater than or equal to, what would happen if it was greater than? Well, that would mean that we want to discard the places where we're equal to 0, right? That would be the only change. Where are we equal to 0 on the function? At our roots, right? So we want to throw out negative 1 and 7. So our number line would look totally the same. right? We would still have positive, negative, positive. But this time, instead of, and we've still shaded in, right, all the positive stuff because we're still greater than 0, right? So all that is still shaded in. But we want to exclude the points where we're equal to 0. So it looks like this. This means our interval notation would look like negative infinity to negative 1, parenthesis, and then parenthesis 7 to infinity. Okay, let's look at another example. Let's say we're looking for negative 2x squared plus x plus 8 is less than or equal to 0. All right, so we need to factor. We need to start out by finding our roots, right? We want to find our roots so that we can put them on the number line. What are our roots here? No, can we factor this? We cannot factor this, so we do need to use the quadratic equation, quadratic formula. So we have, again, negative b plus minus square root b squared 4ac over 2a. So we have negative b is 1 plus or minus square root of 1 squared minus 4 times a is negative 2. C is 8 divided by 2 times negative 2. We simplify further, we get negative 1 plus or minus the square root of 1. Negative 4 times negative 2 times 8 is 64, positive, so plus 64. All over 2 times negative 2 gives me negative 4. So we've got negative 1 plus or minus the square root of 65 divided by negative 4. So we have two roots. Negative 1 plus the square root of 65 over negative 4, and negative 1 minus the square root of 65 over negative 4. So they're ugly, but they're our roots. We need to put them on the number line. How do we know which one is larger than the other? How do we know which one goes on the right and which one goes on the left? That's very important. They need to be in order. Right? So which one of these is smaller? Can we assume that the one with subtraction is smaller than the one with addition? Well, let's check it out. Let's see what they are in decimal form. So we've got negative 1 plus the square root of 65 over negative 4. That one gives me negative 1.766. Let's do subtraction. Minus gives me 2.266. So actually the one with subtraction was smaller, larger. So this one needs to go over here. In order to avoid writing all of it out, I'm just going to use the decimal form. 2.266 and negative 1.766. Now, having it in decimal form is also helpful because it's way easier to pick numbers now, right? If I was looking at this, I wouldn't be able to tell you what was greater than or less than that without thinking about it for a while. So with this, I can easily say, oh, okay, a good number to test that's smaller would be maybe negative 2. So let's test negative 2. So we have negative 2 times negative 2 squared plus negative 2 plus 8. So we have negative 2 times negative 2 squared is 4. So we have negative 8 minus 2 plus 8. So we end up with negative 2. So this is negative. I test something here. something between negative 1.8 and 2.3 is 0. It's a great one to choose. Again, because when we plug it in, right, this term and this term become 0. So we're just left with 8. This is just 8. That's definitely positive. And then if I wanted to test something over here, I can choose something that's larger than 2.266, which is 3. So I have negative 2 times 3 squared plus 3 plus 8. 3 squared is 9, so I have negative 2 times 9, which is negative 18, plus 3 plus 8. That gives me negative 7. So that's negative. Where do I shade in? Well, we are less than or equal to. The value of the function at these 2 points is 0, right? That's their roots. That's the definition of a root. So we can include them because we're looking for less than or equal to. So we can go ahead and put closed points there. And we're asking for less than or equal to. Less than 0 is negative. So that's these guys. Here and here. So if I put this in interval notation, right, I start at negative infinity, and then I get all the way to this first root. So in WebAssign, it's going to want us to put in the exact answer. So that means that I can't write negative 1.776 because I've rounded. I have to write this guy. So negative infinity to negative 1 plus the square root of 65 over negative 4. And we include it. Union. My second root, which is this guy, included. So we have negative 1 minus the square root of 65 over negative 4 all the way to infinity. This is my answer. Okay, we had a short lesson today. That's all I have. Thanks for watching.